So hey guys, we'll be seeing about the Diffie-Hellman algorithm in cryptography and network security. So the introduction. The Diffie-Hellman algorithm is being used to establish a shared secret that can be used for secret communications while exchanging the data over a public network. Using the elliptic curve to generate points and get the secret key using the parameters. The first one is for the sake of simplicity and practical implementation of the algorithm. We will consider only four variables: the one prime p and g, a primitive root of the p, and two private values a and b. P and G are both publicly available numbers. Users say like Alice and Bob pick private values A and B and they generate a key and exchange it publicly. The opposite person receives the key and then generates a secret key for which they have the same secret key to encrypt the data. So the image shows the step-by-step explanation which follows, where Alice has the public keys P and G, when Bob has the public keys P and G. The private key selected is A and private key selected is B from Alice and Bob respectively. The key generated is X is equals to G of A mod P, and for the Bob, key generated is Y is equals to GB mod P. The exchange of generated keys takes place where key received is Y and key received is X. Generated secret key is nothing but Y power A mod P, and the generated key of the Bob is nothing but X power B mod P. Algebraically, it can be shown that Ka is equals to Kb. Users now have a symmetric secret key to encrypt the data. Example: Alice and Bob get public numbers. P is nothing but 23 and G is 9. Alice selected a private key which is A is equals to 4 and Bob selected a private key which is B is equals to 3. Alice and Bob compute public values where Alex X is equals to 9 power 4 mod 23 which is nothing but 6 and Bob which is 9 power 3 mod 23 which is basically 16. Then Alice and Bob exchange public numbers where Alice receives public key Y is equals to 16 and Bob receives public key X is equals to 6. Now Alice and Bob compute symmetric keys where K is equals to Y power A mod P which is nothing but the 9 and Bob gets X power B mod P which is also nothing but 9. 9 is the shared secret key. Now the applications and limitations of Diffie-Hellman algorithm. So the Diffie-Hellman algorithm is primarily a protocol that is used for key exchanges. Using this initiative protocol, two parties will derive a common secret key by communicating each other. The security of Diffie-Hellman algorithm is mainly based on the difficulty of computing the discrete logarithms. Applications of Diffie-Hellman algorithm. Many protocols use the Diffie-Hellman algorithm to enhance security, and few of them are secure shell SSH. SSH is a secure network protocol that can be used to transmit files and log into distinct machines. SSH uses the Diffie-Hellman algorithm to allow secret key exchange between the client and server and secure data transfer. Next one is a TLS, transport layer security. Follows SSL, which is secure sockets layer and encryption protocols that are used to protect online communications. These protocols use the Diffie-Hellman algorithm to safely exchange encryption keys, preventing data manipulation and eavesdropping also. The public key infrastructure (PKI) to secure communication over the internet. PKI uses a system of digital certificates. When certificate authorities add public key encryptions, PKI uses the Diffie-Hellman algorithm to exchange encryption keys securely while preserving data integrity and the secrecy. Internet key exchange (IKE) is a protocol that is used to establish the secure virtual private connection. IKE uses the Diffie-Hellman algorithm to create a secure repeat connection and securely exchange encryption keys. The Internet Protocol Security (IPsec). Security protocol known as the Internet Protocol Security (IPsec) is used to protect the online communications. IPsec uses the Diffie-Hellman algorithm to exchange encryption keys securely while preserving the confidentiality and integrity of data transmission. The limitations of Diffie-Hellman algorithm. The following are the limitations of Diffie-Hellman, which are lack of authentication procedure. The algorithm can be used only for the symmetric key exchange. As there is no authentication involved, it is unable to man the middle attack. As it is computationally intensive, it is expensive in terms of resources and CPU for performance time. Encryption of information cannot be performed with the help of this algorithm, and the digital signature cannot be signed using Diffie-Hellman algorithm. So we'll be seeing the vulnerabilities of Diffie-Hellman key exchange. The Diffie-Hellman key exchange, also known as the exponential key exchange, is a widely used and trusted technique for security exchanging, as we know that it is a widely used exchanging crypto keys over an insecure channel. However, like all cryptographic systems, it is not completely immune to attacks and vulnerabilities. Some potential vulnerabilities of the Diffie-Hellman key exchange includes man-in-the-middle attack. An attacker is able to intercept and modify the message exchange between Alice and Bob during the key exchange. They may be able to impersonate Alice or Bob and establish a secure channel with the other party. This can be prevented by using certificate-based authentication and or by verifying the authenticity of the messages using messages authentication codes (MACs). Small subgroup attacks. If the prime number P used in the key exchange has a small subgroup, an attacker may be able to use this to their advantage to recover the shared secret key. To prevent this, it is important to use a large prime number with no known small subgroup. The secret shared A and B used in the private key exchange are not chosen randomly. An attacker may be able to use this to their advantage to recover the shared secret key. To prevent this, it is important to use a strong random number generator to generate their secret key. So some of the examples are SSL and TLS, the secure socket layer and transport layer, which I told earlier, use the Diffie-Hellman on a secure channel between a client and the server. And the SSH, the secure shell, we use the Diffie-Hellman to establish a secure channel between a client and the server. This allows users to securely log in onto the remote server and execute commands and transfer the files. VPN, we all know that VPN such as IPsec and OpenVPN uses the Diffie-Hellman key exchange to establish a secure connection between the client and the server. And the SFTP, the secure file transfer protocol, uses the Diffie-Hellman key exchange to establish a secure channel between a client and a server. This allows users to securely transfer files between two systems